Paired data and scatter plots. Here we'll go ahead and dive right into our student notes, so please have those out and begin to follow me. Make sure you fill out the blanks and let me know if you have any questions. Let's go ahead and draw and interpret a scatter plot for a set of paired data. Researchers often want to determine if a relationship between two variables exists. To do so, the researcher collects data consisting of two measures that are paired with each other. One variable is the independent variable, and the other is the dependent variable. The independent variable can be manipulated. It is known as the explanatory variable and is called x. The dependent variable, which cannot be controlled or manipulated, is known as the response variable, and it is usually known as y. The independent and dependent variables can be plotted on a graph called a scatter plot. The horizontal axis is labeled with the name of the independent variable, and the vertical axis is labeled with the name of the dependent variable. The coordinates of the axes are determined by the smallest to the largest data values of the variables. A scatter plot is a graph of the ordered pairs xy of numbers consisting of the independent variable x and the dependent variable y. The scatter plot is a visual way to describe the nature of the relationship between the independent and dependent variables, even if the scales are not the same. To analyze a scatter plot, researchers look at the pattern of the points on the graphs. Researchers look for positive linear relationships when the data points increase from left to right. Negative linear relationships when the data points decrease from left to right. Curvilinear relationships or other nonlinear relationships, or no relationship at all when the scatter shows no pattern, line, or curve. Here are some examples. In the upper left, as you can see, as we go left to right, there's a very strong linear relationship. In other words, a strong positive linear trend. Example B, as we go left to right, it's clear to see there's a strong negative relationship. The next one, you'll notice that it gives sort of a parabolic relationship. And this last example has no relationship. As you can see, the data points are kind of all over the place. There's no real trend going left to right. The procedure for drawing a scatter plot is quite simple. Step 1. Draw and label the x and y axes. Step 2. Plot each point on the graph. Step 3. Determine the type of relationship, if any, that exists for the variables. So getting right into an example, let's construct a scatter plot for the data obtained in a study on the number of absences and the final grades of 7 randomly selected students from a statistics class. Now, since you have this on your student notes, just follow along. As you can see, I have my x and y axes labeled, and I will go ahead and go in order. The first is the student who had 6 absences. That student received over an 80%. Next was the student with 2 absences, did slightly better in the class with 90%. The student with 15 absences got something in the 40s. And we just go ahead and continue to plot our points. As you would imagine, there appears to be a negative linear relationship between the number of absences and the final grade, which makes sense due to the fact that the more you miss class, the more likely you'll miss out on important information, causing your grade to suffer. Another example, the number of teachers and the number of pupils per teacher. A researcher wanted to check for a relationship between the number of pupils per teacher and the number of teachers. The data from a randomly selected sample is listed below. Once again, we simply just plot the points, and I will go in order from 1 to 10. Now, what sort of relationship can we see from these data points? In this example, there actually appears to be no strong positive or negative linear relationship between the number of pupils per teacher and the number of teachers. It's not really trending up or down from left to right.